Thank you very much. I know it's a new session, but it's the same session. And I see the same people, so thank you. Go to the second part for that session. I'm talking about network and security in Kubernetes or at Kubernetes, inside Kubernetes, to network and security guys. Cover the first part, go to the second part. Who is load balancer service and service mesh? And again, don't fret, take it easy. Who is the idea? Originally, when the CNF defined the Kubernetes, we need to expose the application outside the world. And at that moment was enough just put a TCP port outside. And that service was server load balancer. When you go to Kubernetes, it says service load balancer is a layer 4. It's just a TCP port, usually. But, of course, with the time, it's not enough a layer 4. But, included in the same cluster, it's possible to have different applications. Always seeing, waiting in the same port. How classify who as who is only layer 4 information. So I need a layer 7 information. The concept is starting with the people in Red Hat, with OpenShift, with router, and the CNF say ingress. So sometimes you see back and back in both concepts, but it's the same. Ingress, OpenShift routers talking about a layer 7 load balancer. But it's enough with the load balancer. You have, for example, for us, Contour project, yeah. It's a layer 7 ingress balancer, yeah. But it's enough? Really it's enough? Only handle the layer 7 information? No. You need C traffic. You need handle the IP assigned to the public things. You need handle the elastic way to handle the things. You need a lot requirement for security guys. So it's not enough, that basic concept. You need more things. The same thing you need today for the traditional application. Repeat, the concept is the same, change the environment. Or tagger, or objective, does remain the same. You need focus in the target, not in the tools. The tools is deterministic for what is my environment. So your skill and your requirement remain. When you do things, usually, that is true, I have a load balancer. Yeah, ready? No. Above, you need handle. Assign the IP. Define the DNS register for the people see your application. And, of course, something to protect, include the WAF. So, usually, it's an additional tool. Enough? No. Because maybe I need some disaster recovery. So I need handle the global balancer. So you have, when you're thinking, the ingress alone is not enough. What is the concern for us? Yeah, you had a lot of tools in the ecosystem of the open source to provide different tools. Yeah, it's possible. But what is the challenger? Each tool is a silo tool. Who Google touch everything? You. And you have time to learn to each open source project to see how connect every project you have time? No. Oh, sorry. It's too much quickly. So the idea for us is taking these concepts in a single enterprise, when they say enterprise grade solution. Now, come on. And that is the idea inside NSX Advanced Load Balancer, formerly or friendly known AVI. That is guy, remember, yeah? It's a ingress, it's a layer 7, layer 4 load balancer, yeah, ingress cover. Handle the assign the IP for the virtual server, yeah. Is possible to define DNS records? Yeah. Include security, include the WAF in the solution? Yeah. Is it for VMs? Yeah. Is for physical stuff? Yes. Is for public cloud? Yes. Is for Kubernetes? Yes. So it's possible to use the same tools and simplify. And this one, visibility. Real thing. Some months ago, I delivered the session in BMAC Argentina, and a guy for the customer see my session. He said, I see a Waldemar yesterday, yeah, talking about that. So, okay, call to Waldemar for formal presentation for us. And explain this or that for network security team. And when you see the visibility, the deep visibility you have only for power on, nothing special, it's just power on the virtual service. That is maybe, I say, a natural way for VMware in network security. If you see the packet, it's possible always taking a picture. So for us, it's nothing special. It's just the packet throw me, I take and collect information. And when you start to see a lot of information, you see, the guy say, Waldemar, yeah, I handle a load balancer. Is possible to create some way to deliver this view information to the DevOps teams? I say, no, it's not possible. You must create a read-only user, allow each application owner to see your also details. Because that guy has other tools, tons of observability, and now I don't remember where from. But that is inside the service, not outside the structure. This is the other view needed. So create a read-only view. It's okay. And deliver that user for DevOps, for owner, for application. And forget create report for that guy. That guy see your application running, what happened. And don't talking with you. If see something wrong, the pod is working bad or something. It's more quick to fix the problem. The rich visibility in the AV-NSX Advanced Balancer is a key. Everybody needs visibility. Everybody. If you have the solution ready, go. Who knows something NSX Advanced Balancer? You know? Yeah? No? Perfect. So, introduction. Who is my best friend, Avi? You have in any network security things in VMware, usually it's the same philosophy. Central management control plane, distribute data plane. It's always repeat, the same. You have a central point, a controller. That controller is a VM running where do you want, in your on-premise, in the public cloud, or included in some case in the own VMware Cloud service, SaaS service. It's the place you have the definition, you take in the telemetry, the point you handle and control. But the data plane is delivered in each place you need. It's possible in the on-premise, it's possible in the public cloud, it's possible in the bare metal. Depends the condition, is I move the data place where I need it. But I have a single way to control everything. And ring to handle everyone. You have the possibility, and this is good. What is the requirement for the endpoint to use AVI? An IP. A VM, an IP. A VM, no. Every endpoint with IP address, I can see from the data plane is a chance to deliver my service. Doesn't matter it's VM, doesn't matter a physical server, maybe, I don't know, a mainframe, a Kubernetes, doesn't matter. So it's the only a single solution to balance everything. It's not only for VMs, it's not only for VMware products. It's the same solution. You have central orchestration, you have elasticity. You need more throughput. You create additional data service engine. If the demand decrease, you go down. So you need pay what I think in 3 years forward. I can pay for what service, one more buffer, and when you need more, add. Oh, is I have this license allocated to my on-premise, but now I need more service now. Taking my on-premise throughput and move to the public cloud. It's a distributed way. That is elasticity. Resilience, si something is broken, I lost the service. No. This guy is ephemeral, like in a pod. Here is up, waiting for the order to what is my work, taking the information, deliver. If I die, doesn't matter. Create a new one, this is information, I go on. It's no key. You have, and that is possible for by self-protect or use the natural protection in your environment, be it high availability or equivalent in every place. Other one, elasticity. The automation. It's possible for this guy talking with the DevOps and create the service in automation way. Yeah. Why? Yeah, the idea Kubernetes. The DevOps guy, the application, say, I need in the YAML file some service load balancer. I take in the information and create the service. I need ingress, taking the information. So it's possible to include in the continuous delivery and continuous integration pipe, include the creation of the load balancer. Yeah. So it's my decision is deliver or no that power for the application team. But I have the option. And I have a lot visibility, repeat, a lot, and additional service. Why? When you're talking about security, nothing is static. If you're thinking, okay, I need power on the WAF. Okay, what is starting? For us, if you don't know what application, OSWASP. The top 10 OSWASP is taken for the first protection. I have bot detection. So I need some way to update my security stuff. That is a cloud service. So if you now see NSX a load balancer, please use the cloud service. That a lot, for example, the templates for the WAF for the application, always deliver in that way. Because it's more dynamic, because the security today is nothing static. You need still day by day. So dynamic service updating is included. Kubernetes. Okay. I know official name is NSX Advanced Load Balancer, but everyone, AVI, and the operator still say AVI. Okay, it's the same guy. You have two parts in this, or three parts. One, the same controller, use it. And these two guys, operator, name. Operator is an executing pod inside each Kubernetes cluster. What is the function? These people move a packet. Is a watcher in the API to see when some people say, I need server balancer. Let me. I need ingress. Let me. Capture the request to load balancer and ingress. And this request is sending to the controller to create the virtual server. So network security load balancer need to touch the AVI controller to create a new service for the Kubernetes? No. The guy, when you put kubectl apply -if whatever, is include something load balancer or ingress, a virtual service created. And has a second part when you handle more than one cluster, and you have some disaster recovery, active, or some application with path A and B, and use similar to direct that information, like a global service load balancer. So you have a second operator, M for multi, to handle that case. So in that case, you don't create a virtual server. You create the rule for global service load balancer. Okay, good. Come on. Who is who? Okay. First thing, usually, include concrete, the ingress controller delivered in the open source project is a pod in the cluster Kubernetes. So when you create, usually contour is an example. You need something inside the cluster pod to run the ingress service. First problem is inside. You compete with the resource with other people. If you need more advanced security stuff, you're starting to grow. So you taking too much resource for the Kubernetes cluster against the VMs. So in our case, it's not inside. Who is the same service engine running a VM, is the same data plane. It's not running, the egress running here. Nothing running inside. Only the AKO watcher see what is request. So if something is wrong here, you still have the possibility to grow and nothing affect your service, and you have split duties in both cases. And these guys, of course, save it to Kubernetes cluster or other endpoints. What is the idea? I take in this AV controller, installer, whatever, then I create the cloud, is the mention is the way to interact with the infra from the AV controller. You then create the data plane, the people to talking in the front to the customer in the back with the service. And then you talking with the people handle the Kubernetes, I create the installation for my operator. What is included in the operator? In the operator, you say, that is the AV controller, that is the service engine grow, that is, you got the information to connect to the infra and starting to see what happened. And with that, you deploy. This is explanation to Kubernetes vanilla, Tanzu, you have other options. Install with Helm, in short, install the application, the AKO inside the Kubernetes. Doesn't matter. It's the type, but you put the pod for watcher, see what happened inside. And then establish, and I am ready. I am inside the Kubernetes, ready to connect with the controller, waiting the people starting to kubectl minus if something. In that case, when the people go, the developer go and create directly, don't touch with the AV controller, touch naturally with your Kubernetes cluster, and put your service load balance, your ingress, and what information is sent here to the controller in the cluster, you watch with the AKO what happened. I taking that information, in that information say me maybe the FQDN for the application, maybe tell me what is the port, maybe tell me what is the location. Well, information to define the service. I taking that information, I deliver that information to the controller because I talk with the controller, and the controller create the service. Create the service for example, create the DNS record for the application and create the virtual server to wait to come the user to me. The IP for the application. And the clients go to start and consume. How consume the cluster? Go to the DNS. AVI is a DNS server, yeah. It's possible to surrogate a subdomain to handle, define the record in DNS. Tell to the user who is this name is the IP. Go to the VIP, consume with the service pool, in that case my put, process the information, come back, account to the client. So I see the picture. Nothing strange. It's a load balancer. Customer, server pool, or VIP, VIP, back to server pool, process, come back to me, come back to the client. But it's Kubernetes. Doesn't matter. It's a load balancer. thinking in the concept. Don't go in the rabbit hole too much quickly. Think in the concept. It's just a load balancer. When you go, in this case, when you have more Kubernetes cluster or more sites, you need something multi-site. So you have a multi-cluster operator. Multi because you have more Kubernetes cluster. The concept is very similar. In each cluster, you have the same guy, Eiko, thinking your local service, but you have additional people, another operator, just is a controller, is no data plane. What is the responsibility in the MCO? C is in the YAML file, exist, attack, mark. This application is not only local, need split, protect. If I see that mark in the request, I take in that mark and not only create a record locally for each DNS, maybe I create a single record with two IP belong, one IP, the VIP in each side, I am DNS server, but the difference, I use my healthy check with the VIP to define is answer with this IP in the A record or no, and I have policy for define this for this country, go to that, or maybe it's internal, go to that IP. So all intelligent stuff in HLSS is you. The guy, DevOps, need mark this application need support in multi-cluster or multi-site or wherever. So it's the same. The concept you have the local load balancer, see here before with the AKO, and now you have the option also with the MCO handle the GSLB, the global service load balancer. But it's a global service load balancer. Yes, the same global service load balancer always you use an NSX advanced load balancer AVI, but now for Kubernetes. The guy in the Kubernetes side needed to know details about that. The guy sent kubectl, create the service, maybe mark the application for multi-cluster, multi-location. That's enough. For us, I need run to create something quickly. No. I create the infra and die zero to automate deliver the service. What is my function? See, happen, is the resource good, is the resource bad, I have some problem. I don't pick rogue every day running with the people. Okay, everything is way, okay, checking and go what they need, but the infra is lie by itself. Okay, shall I explain it? Okay. What is this strange thing? I talking something special before. Oof, the time is right. What is the thing to preserve for us? What is my talk in backend? You have three options. First option, when you're talking about no port. What's no port? You have some C proxy, an IP table in each node to hear in each node for some pod. Doesn't matter if pod exists or not in the worker. What happened? Sometimes go to this guy and you have a local pod, okay. But sometimes go to the same guy but go to the other pod. So I don't have control, it's locally or remote. Work? Yeah. Especially for layer 4 service? Yeah. But if you need some persistence, layer 7 service, cookie, whatever, doesn't work. It's good, simplified, but doesn't work. Basic UDP service, yeah, but TCP service depends, it's HTTP, whatever, persistent doesn't work. Second part, cluster IP. In that case, you see the pod. You see the IP in the pod is C for the network routing. So I can go directly to the pod. Problem, I need use IP router. What happened? Usually in the current world, each cluster has that IP repeat and repeat and repeat. So I need to create a special network for each pod so the automation is not in touch. I need to handle that variable, so it doesn't work. But what is okay? Because I see the pod, persistent is perfect, work. So I close in this, no. You have the third option with Antria. Antria create, you don't know the IP in the pod, but create a destination NAT here only for this pod, only for this pod, only in the worker where exists the pod. So now my pool, server pool is this IP with this port, and see directly the pod doesn't matter the IP inside the pod. So repeatable Kubernetes cluster definition, only need to see the workers, but you have access to the health in the pod. So my personal preference is that case, but depends you have. In that case, any CNI is supported, but no port local today is only Antria, the part one. Okay, finish because it's in time, sorry. Quickly recite. The big problem now when you have distribute service and need to connect everything in each port. You have a lot of people create application. If people create own rules in all the deliver code program and need to create something new, go fast. So the problem is you now move APIs. And that problem create a challenger, service and security, because this guy create own security in our source code. Okay, it's possible running, yeah, but I need security connection, visibility, and compliance. Is each people create in our pod, you're starting to see this problem. Who handled the certificate? The certification. Who handled? Expire and expire. What is the rules of security? So, what is the idea? Because I don't have a very good time. You have a handle for that. Tanzu service mesh. What is the idea behind that? You have a single small proxy behind each pod to connection in a single way to handle certified, role policy, and everything. And only for information, you have layer 7 information API. Yes, my bad time. No, handle very well this time. It's possible combine, in 2 ports. Use the GA7 to handle where you go. So you have ABI, you have Tanzu service mesh, and you have option for everything. Yeah, and your question, I need more time for 3 and 4 parts to everything inside TKGG. And it's enough time for me. Thank you. Sorry. My